Hey guys, in this video I want to show you how to make a simple fluid simulation in Houdini. This setup is very beginner friendly, so let's dive in. So here we are in Houdini. I've created a new blank scene and the first step is to add a new geometry node. So let's add geometry node, and here you can rename it something like fluid R&D, and you can dive inside, and the first step is to add the model into the scene. So to do that you can add a file node. And here with the file node, you can press P to open the parameter tab. You can click on that, and here into $geo, I have my model. So I have created a model in Cinema 4D, and if you want, you can get access to these final project files, including the model, textures, and lighting setup. So if you want, just check the link in the descriptions. So here I will import my model in FBX, so I will click on accept, and now we have the model. So you can see that the model is quite huge for now because this is model in Cinema 4D, and the scale is not the same as Houdini. So let's add a match size node. And here with the match size node, you can change the target size to 4, and you can click on scale to fit. In that case, it will resize the models and put it into the center of the scenes. So now you can see that we have the cap here and the tube here. So the idea is to put the cap closed on the tube. So to do that, you can add a split node to split the tube from the cap, and here you can just modify the position of the cap on the y-axis. So let's add a split node. And here with the split node, we can select, for example, the tube, which is the base. And now for the first output, we have the base, so you can add a null and you can rename it something like base. And for the second output, we have the cap, so you can add another null and we can rename it. So now we can add a merge, and we can merge that together. So you can select these two nulls and you can plug them into the merge. So now you can add a transform node for the cap. In that case, we can move the cap a bit up on the y-axis. So let's add a transform node on the right string. And here we'll go into front view by pressing space 3 on the viewport. And here to move the cap a bit up on the y-axis, you can go to the transform node, and here you can click on move pivot to center it. And you can click on these little icons. In that case, you can move it up on the y-axis with the green handle here, and maybe you can move it to something like this. Let's put the value at 0.6. So now you can go back in the 3D view by pressing space 1 on the viewport, and now we can add normal node. And now you can remove some attributes, so let's add an attribute delete. And now for the attribute, we can select the normal, UVs, and name. And you can click on delete non-selected. In that case, it will keep only these 3 attributes and remove everything else. So now let's add a match size node one more time. And now you can click on that. It will put the model on the center of the scenes. So now you can add another transform node to place the tube correctly into the scenes. So let's add a new transform node. And here with this one, you can select this little icon and you can place the tube correctly. So you can make it, for example, something like this. And now to go to local view, you can press M 2 times. And now you can move a bit up on the y-axis and you can make a little rotation, something like this. And I think we are good. So maybe in my case, I will change the value here to 0.5. I'll change this one to -17, this one to -38, and this one to -47.5. Now let's add a bit more resolution on the model, because for now you can see it's a bit low resolution. So to do that, you can add a subdivide node, and here you can change the depth. Instead of 1, you can put it at 2. In that case, we have quite high-res geometry. Now let's add a null to specify this is the output of the geo, so you can rename it out tube. So now let's create the collider geometry and collider volume for the fluid simulations. So to do that, you can add the collision source node. The first output of this node is a collider geometry. So you can add a null and you can specify this is our out col geo. And the second output here is the volume. So you can add another null, and here you can rename it something like out col vol. And here you can see the resolution of the volume is very low. So you can go into the collision source, and here into the volume tab, you can change the voxel size and you can reduce it to something like 0.005. So now we have the collider geometry, we have the collider volume, and we have the output here to render the tube at the final scenes. So now let's create the source for the fluid emission. So to do that, let's add a line. Let's plug the line here and make that into pink and make that blue. So in that case, we have this one visibles and we have the line here. So by default, the line is on the y-axis and we want to get the line on the x-axis. So you can put 0 here for the directions and you can put 1 on the x-axis. And to keep the line at the center of the scene, even if you change the length of the line, you can just put the length parameter, right click, copy parameter, and you can put that to the origin, paste relative reference, and here you can divide that by 2 and you can put that to the negative. And even if I change the length of the line, you can see the line stay in the center of the scenes. So let's put the length value at something like 2.42. So now let's scatter some points on this line. So let's add a scatter node. In that case, we can create different points on the lines. And here by default, the value is at 1000. It's a bit too much. So in my case, I will put the value at 5. In that case, we can get 5 geometry for the fluid source. But it's up to you. You can increase or decrease this value if you want. You can also play with the seed to change the position of the point on the line. And you can also change the relax iterations. So in my case, I will keep the global seed at 0 and I will increase the relax iteration to 20. So now let's add a copy to points. In that case, we can copy some geometry on those points. So let's add copy to points and let's plug the points on the second input and let's add the spheres. And let's plug the spheres on the first input of the copy to points and let's see the result. So for now we have that. So into the spheres parameter, you can select the spheres and here you can change the primitive type to polygon. You can change the radius to 0.3, 0.75 and 0.15. So now you can also change the uniform scale to 0.5 and you can increase the frequency to 8. So now we have this kind of result. So now it can be a good idea to have some randomness into the Y position of the different spheres. So to do that, you can add a point jitter on those points. And here the point jitter add a bit of jitter on each axis. So you can see here. So basically we want to add only the jitter for the Y axis. So you can remove for the X and for the Z. Keep only for the Y axis. And here you can change the seed if you want to get different positions. So in my case, I will put the seed at 1.07. Also, it can be cool to add a bit of randomness on the P scale of each different sphere. So to do that, we can add an attribute adjust float on those points. And here for the attribute adjust float, by default, we have the P scale attribute. And here you can keep on add and you can change the pattern type to noise. And here you can change a minimum and maximum value. So maybe you can put the maximum value to 1.8. And now you can define a ramp for the different scales. So maybe you can go for something like this. And here you can just shape the different P scale you want for the different spheres. So it's fully up to you, but you can add a bit of randomness like this. Also, you can change the element size to 0.01 and you can also play with the offset if you want to change the different scale for the spheres. So in my case, I will put the offset to 5.25.
Imagine having access to over 40 hours of exclusive Houdini tutorials, and that library keeps growing every month with brand new content. On Artilabs, you'll find in-depth Houdini tutorials covering motion design, simulations, product visualization, and more. Plus, you get access to all project files so you can follow along step by step. And right now, we're offering an extra 20% off the annual membership, on top of the 10% discount already included when compared to the monthly plan. This exclusive deal is available for the first 30 people, so don't miss out. Click the link below, your 20% discount is applied automatically. Secure your spot before it's gone.
So now you can change the position of the spheres to get them above the tube. So let's add a transform node after the copy to points. And here with the transform node, you can change the position on the y-axis to something like 3. And now you can go to the top view by pressing space 2. And here you can change the rotation just a bit. So you can select the transform node, you can select these little icons, and here you can change the rotation on the y-axis to something like this. And now you can go back to the 3D view by pressing space 1, and here you can press M multiple times to go into local space, and you can change it on the x-axis to maybe something like this. So now we can break those spheres into small different parts to add different viscosity value for the fluid simulation. So to do that, you can add the point from volume. And here for the point from volume, maybe we can keep everything by default for now. So let's add a Voronoi fracture. And let's plug the transform node on the first input, and let's plug the point on the second input for the Voronoi fracture. And now we can add an exploded view just to get a preview of the break. So you can put that visible. So now you can see that we have lots of small parts for the sphere. I think it's a bit too much for now. So you can select the point from volume, and here you can change the point separation to 0.2. And now you can play with the jitter scale and jitter seeds. So in my case, I will put the jitter seed to something like 2.15, and I will change the jitter scale to 0.2. And now if you want, you can just play with this value if you want to get different pattern. So now let's add a connectivity node to get the class attribute per different pieces. So let's add the connectivity node, and let's keep the connectivity type to points. And to get the results of the class attribute, you can visualize it by clicking on the information node, and you can click on class, and you can see that we have different class value for each individual break pieces. So now let's create the fluid source. So to do that, you can use the flip source. So now we can keep everything by default, but later we need to change the particle separation and voxel size. So now we have this, and you can add a blast node, and we can keep only the particles, so we can remove the surface. And now you can add an attribute transfer. And you can plug the points on the first input, and you can plug the connectivity node to the second input of the attribute transfer. And here we can transfer the class attribute we have created with the connectivity node here to the points. So to do that, you can select your attribute transfer, and here on the point, you can select the class attribute. So this is the attribute we want to transfer from the second input to the first input. So now to get a bit more resolution on the points and to see the result of the attribute transfer, we can increase the resolution of the flip source, but later we will change this value based on the DOP simulations. So maybe you can put the particle separation to 0.01 and same for the voxel size. And now here we can add a color node. And here for the color node, we can add random from attributes, and you can select the class attribute. And in that case, you can see that we have added a class attribute for the points for the fluid simulations. And with this class attribute, we can create a different viscosity value for the point for the fluid simulations. So to do that, let's add an attribute wrangle. So let's start by creating an integer seed variables. So let's type int seed is equal to channel I, and we can type seed for the name of the channel. And now we can set the viscosity value. So you can type @viscosity, which is the name of the attribute, is equal to fit. And you can create a random value based on the class attribute. So you can type rand @class plus our seed variable. And now we can remap this value from 0 to 1 to channel float. Maybe we can create a channel for the minimum viscosity. So you can rename it min visc. And you can create another channel for the maximum value. So you can type channel float max visc. So now you can create all those parameters by clicking on these little icons, and you can change the seed, you can change the minimum viscosity value and maximum viscosity value. So in my case, I will put the minimum viscosity at 150 and the maximum to 250, and here I will change the seed to 4. So in that case, we have created a viscosity attribute for the points, and the viscosity attribute got a random value between 150 and 250 for each individual class attribute here. So now let's add a null to specify this is the output for the source. So you can rename it out source. So now we can dive on the fluid simulation. So let's add a DOP network. And here we can rename it fluid sim. You can dive inside. And here we need a flip solver. We need a merge node to add the collider geometry. We need the gravity force. And you can plug that to the output. We need a flip object. So we can plug that to the first input of the flip solver. We need a volume source, and you can plug that to the last input of the flip solver. And we need a static object to import the tube on the DOP networks. So you can plug the static object on the merge and make sure the static object is on the left. So to do that, you can select the merge, press Shift and R. And in that case, you can see the static object is on the left. So now let's import the collider geometry on the DOP net. So here you can select the static object. Here for the subpath, we need to import the collider geo. So you can click on that. You can go to your object, and in my case, it's called outCollGeo. So now we have the geometry. Now we can go to the collisions. You can change that to volume collisions, and you can change the mode to volume sample. Now you can import the proxy volume. In my case, it's called outCollVol. So now we have the volume and the geometry. So now you can go to the flip object. You can remove this default cube. Now you can copy the particle separation. Right click, copy parameter. You can go back to the object by clicking on this, and you can go to the flip source node. Right click, paste relative reference, and you can multiply that by 2. And you can right click, paste relative reference on the particle separations. And for the jitter seed, we can type $F. In that case, the seed will change for each frame. So now you can go back to the DOP networks. And here we can reduce the particle separation to 0.01. We can import the source to the DOP net. So to do that, you can go to the volume source. Here you can select on the subpath the source we have created on the SOP. So you can click on that. And in my case, the source is called out source. So I can click on accept. And here on the initialize, I can initialize the source flip. So now you can see that we have the spheres as a source, and we have the tube as a collider. So now you can go to the flip object, and you can go to guides. And here you can go to particle tabs, and you can change the visualization. Instead of sprite, you can put it to particles. So now you can see that we have a huge purple square here. So this is a domain for the fluid. So by default, the size is quite huge. So you can reduce it by going into the flip solver. Here into the substep, I will increase to 4 and 5 for minimum and maximum. For the particle motions, I will add the ID attribute. On the receding tab, I will disable the receding. And for the volume motion here, I will change it to swirly. And here I will change the box size to maybe 5 and 5 and let's say 7. So for now you can see the box is too small because that we have some sphere above the square. So we need to increase on the y-axis to maybe 10. I think 10 is good. And maybe we can increase it to 6 and 6. Yes, I think something like this is good. So now you can just make that invisible, so you can disable this little visualization for the box. Now on the viscosity tab, you can click on enable viscosity and you can click on viscosity by attribute because we have created the viscosity attribute on the sub level with the attribute angle. So now you can select the static object, you can go to the physical tab and here you can decrease the friction to 0.2. Now you can add a pop drag. You can keep the value at 1, but if you want, you can change different value for the air resistance if you want to get a bit more different results. And you can add a pop wrangle. And here on the pop wrangles, we can decrease the velocity attribute slightly over time. So to do that, you can type v at v times equal 0.95. So you can also select your flip object, and here into physical, you can tweak the density parameter. In my case, I will increase it to 5000 to get a bit more nice drip on the fluid, but you can tweak this value if you want. And for the volume source, here we want to emit the fluid only on the first frame. So here for the activation, we can type $ff equal 1. In that case, it will emit the fluid only at the first frame. So now let's click on play and let's see the result of the fluid simulations. So now you can see we have the fluid simulation. Of course, by changing the sphere's position and the seed on the viscosity value and so on, you can get very different results. So you can tweak some parameter if you want. So basically you can just increase the resolution now for the final simulations. So you can put the value at something like 0.0, maybe 5 will be enough for these simulations. And now when it's done, you can go back to the sub level by clicking on this. You can add the DOP import fields. And here you can import your DOP networks into this one. So you can drag and drop the DOP networks. And here the DOP node is a flip object. So you can go here. You can select your DOP networks. And in my case, it's called flip sim. And my DOP node is this one, the flip object. So I can click on accept. And now for this one, I can click the preset flip fluids. And now it will import my fluid simulation to the sub level. So now you can add a file cache to make the simulation in cache, and you can put that to the file cache, and you can rename it something like flip sim. And here you can put that to explicit. You can type cache to create a cache folder, and you can put $os folder, which is the name of the node. And now you can cache a simulation for, let's say, 120 frame. So you can right click delete channel and you can type 120 here. And now you can click on save to disk. So now let's create the mesh for the fluid, and you can see that the fluid is colliding with the bottle at the frame. So maybe we can start the rendering at the frame something like 68. So we can offset the simulation to get the frame 68 at the first frame of the timeline. So to do that, let's add a time shift. And here is a time shift. Instead of $f, you can type $f plus 68. So now we have the 68 frame at the first frame of the timelines. And now you can add a retime node. And here for the retime, you can make the simulation a bit slower because for now I think it's a bit too fast. So you can put that to delete, you can put that to cubic, and you can change the speed to something like 0.25. So now let's create the mesh for the fluid. So let's add a VDB from particles. Here with the VDB from particles, we can decrease the voxel size to 0.005. And you can decrease the minimum radius in voxels to 0.1. And now we have this. So we can add a VDB reshape SDF. And here with the VDB reshape, you can keep the operation on delete and you can change the offset if needed. But in my case, I will keep it at 1. And now you can add the VDB smooth SDF. You can keep the first VDB smooth on the default value, which is min value 1 and 4. And you can add another one, VDB smooth. And for this one, you can change the operation to Gaussians and you can keep the iteration to 4. But if needed, you can tweak the iteration if you want to get more or less smooth. So now we can convert this volume back to geometry. So let's add the convert VDB node. And here we can convert it back to polygons. So now we have our geometry and you can see it's quite nice. So now let's add normal to this geometry. So you can add the normal node. You can put the normal attribute on the points and you can change the weighting method to phase area. And now let's add a smooth node. So you can smooth the position just a little bit. So maybe you can increase it to, let's say 30. And let's add another smooth, this time for the normals. And here we can just change the attribute. By default is position. So now we can change it to normals. And we can change the strength to something like 80. And now we can add a null to specify this is the output for the fluid. So you can rename it something like render fluids. And here to speed up your rendering, you can add another file cache for the mesh. And you can plug that here and you can rename it something like fluid mesh. And you can put that in cache before rendering. It can be a little bit faster. So now we can see the fluid and the bottle together. So to do that, let's add a merge node. You can select this null and this one, which is the out tube, and you can plug that to the merge. And now you can see that we have the tube and the fluid, and you can see it's quite nice. So now we can go back to the object level. We can add a camera, and we have created different tools in Houdini to speed up and make your life easier. So maybe you can select your camera, and here you can download the composition master tool for Houdini. And here, if you are selecting the camera view here, you can move the camera on the scenes like this. And here, if we are selecting the tool, you have the possibility to add some composition guide. So for example, we can select the camera. In my case, it's the camera 1. So if you add more camera, you can click on refresh camera. And here, let's add the guide color in white, and you can change the aspect ratio. So in my case, the aspect ratio is this one, the one by default. And let's open this one. And now you can see that we have nice guide compositions to make something nice for your camera positions. So let's say that we want something like this. And now to remove the guide from your camera, you can just select the tool and you can click on clean guides. So you can get these tools and you can find them with a link in the descriptions. So maybe you also want to separate your render object from the RNG object here to make something very clean for the render scenes. So here you can make this one invisible. You can go back to this geometry and you can select this null, the null for the fluids. So you can send that to another geometry object with material and so on in one single click by using the plugin called Scene Builder. So here let's select this null, let's select the tool. And here let's send that to another geometry setup and you can rename it something like render fluids. If you want, you can select a material, but in my case, I haven't created any material yet. So let's create that and let's click on create render object. So now you can see that we have a render fluid node created here, and you can see it will add the fluid, a material sub node and a out. So in my case, I don't have created any material here, but if you want, you can assign it or assign the material directly from the UI here if you have created the materials. So you can do absolutely the same for the bottles. So you can select the bottle, you can open the scene builder tool. Here you can rename it something like render tube. And you can add the material subnode and you can assign the material if you want, create render objects. And here we go. And maybe you can also create a studio background. So you can click on add studio background. You can name it something like render background. And here you can add the material subnode with the materials and you can create a studio background. Now it's okay. And now you can place that very fast, so you can put that cleaned. So now we have all the render object with material subnode and we have the studio background. So now we can just change the position with the transform node or directly from the object level here. So maybe you can put that here and here and here. And now everything is nice. So if you want to download this plugin, just check the link in the descriptions. If you want to get access to the project files, check the link in the descriptions. And if you want to get access to premium tutorials, check the link in the descriptions. See you in the next one. Bye-bye. That's it for today, guys. Thanks for watching. And don't forget to subscribe to our channel and check artivoxa.com to get premium 3D resources. You can access to this project file with our Artifiles membership. See you in the next one. Bye.